The plan for this lesson is to discuss data quality, data cleaning, and data integration. First, we will broadly explain the primary data preprocessing tasks, then go over some details about data cleaning and data integration. For the past years, we've been collecting large amounts of data from various types of networks and sensors, then integrating the data which have variable quality and dealing with endless quality issues. So data cleaning involves handling missing data, inconsistent data, and noise. This process is very critical because analysis will not be accurate if the data source have serious quality issues. Because the data has many dimensions and is very large, we want to reduce the number of dimensions without causing knowledge loss. We also want to leverage compression techniques to reduce the data size. Data transformation involves normalization and hierarchy generalization. In normalization, we transform the data to a different scale or standard. For concept hierarchy generation, think about tree-based data structures like ontologies and taxonomies, which help with data analysis. Data quality is a subfield of data management. We want our data satisfies the following measures. Data needs to be accurate because if the data is not accurate, then the results are not correct. Sometimes data collected from sources happen to be incomplete or unavailable. Also, very often there are inconsistencies happen due to the time of updates. For example, some sources may only update their data once a day or overnight because it's a time-consuming process. This will lead to an inconsistent data state. Does the data come from a trusted source? Living in this age of misinformation, one should be questioning everything we read. And interpretability means we need to understand what's going on from the data. Can we explain it? Does it make sense? There are a lot of problems that go under the data quality umbrella. Some of the issues may lead to incorrect data, such as instrument faults and human errors. Also, incomplete data could be a result of an issue inside the data collection pipeline, like a missing entry or a recording error. For instance, the salary should not be a negative value. Inconsistent data has discrepancies in recording, like using an absolute number for an age instead of a data type for the birth date, letters and numbers. Sometimes inconsistency is intentional. People don't like to fill up their birth dates in all of these web forms, so they end up using January 1st as a value. So incomplete or missing data can be a result of many issues. Here are a few examples. Equipment malfunction, like using cheap, unreliable sensors. A result of deletion due to handling an inconsistency issue. Or data might thought to be unimportant at the time of data collection. We have to come up with plans that deal with the missing values, like making inferences. How to handle missing data? There are many reasonable ways to compensate for those missing values. So if the problem only happens with a very small percentage of the data, then it's okay to drop those entries. But manually filling missing values is definitely infeasible, and many automatic ways can be implemented, like using a statistical measure as the mean to smooth those values, or even more advanced methods like using a decision tree that is going to look at the values of the other attributes and then make a decision which value to go with. Noisy data means that there's an error. And this error can be random or unexplained, something wrong with the equipment or how the data was entered, or even an inconsistency issues. So anything that makes the value incorrect is noise. More example, duplicate records, incomplete and inconsistent data. There are several methods to deal with noisy data. Binning is a statistical method where the data is sorted and partitioned into bins. Then we use the value of a statistical measure like the mean or the median to smooth the values in each bin. Regression is a linear method where the data is fitted into a regression function. Then we use this regression function to do a prediction of those values. Clustering helps with create groupings inside the data and then use these groupings to detect and remove outliers. Semi-supervised method involves a human in the loop. So whenever the program raises a red flag, a human should go and inspect. Here's an example to show how binning works. We have sorted values, we partitioned them into equal frequency bins, then computed the mean at each bin. After that, we use the mean to smooth the bin values. So the mean for bin 1 is 9, that's why we smoothed bin 1 values by 9, 9, and 9. Similarly with the 22 and the 29. Smoothing by bin boundaries is a little bit different. So we are going to assign the values to the closer boundary. Here we have 4 because 8 is closer to 4 than 15. Similarly, 28 is closer to 25 than 34. This is the canonical image for clustering, and as you can see what happens in clustering, we look for these groupings and decide what belongs to the group, and we flag what doesn't belong as an outlier. Data cleaning is a very elaborate process, and we don't look at this problem in isolation. We look at it at a data management system level. We also leverage everything inside the data management system to help detect those discrepancies and maybe address them. So using the metadata, which is everything about the data from domain and data types and even statistical measures to detect these issues. One can also check for field overloading. So in field overloading, when one attribute is used for multiple purposes. So let's say I have a field for storing the name, and they've been using the name for storing the first name and the last name. Also, the data management tools can be used to implement rules. Some of these examples checking for uniqueness, consecutive rules, or null rules. In other situations, we might use commercial tools that run on top of a database, like data scrubbing, which use simple domain knowledge like postal codes, spelling checks to find and correct those errors. And there are more advanced methods and tools like data auditing, which analyze the data and can use correlation and clustering to find those problems and address them. Data integration is an iterative and interactive process, so the data lives in multiple distributed sites and stores. So what happens here, we're going to do ETL, extracting a transformation and loading the data into a single data warehouse or store. So why data integration? Because it helps reducing errors, give a better picture what goes inside the data, and it also improves the mining speed and quality. Data integration is an iterative and interactive process, so the data lives in multiple distributed sites and stores. So what happens here, we're going to do ETL, extracting a transformation and loading the data into a single data warehouse or store. So why data integration? Because it helps reducing errors, give a better picture what goes inside the data, and it also improves the mining speed and quality. Schema integration is a pre-processing step in the data integration process. So given two databases, they may be using different names to express the same value that we want to integrate. Look at the customer ID in database 1 versus database 2. They are written slightly differently, but they mean the same thing. So we need to look at the metadata level and make sure they represent the same thing. Also, on an entity and value level, maybe two values are expressed differently, but they mean the same thing. So here, Bill is the same as William. So when we do the integration and the analysis, whenever we see Bill or William, we need a mechanism to say these two values are the same thing. And as you would all expect, data integration will only make data cleaning issues more challenging because now we have integrated data from multiple sources. So it becomes very important to detect value conflicts. Some of the example, let's say one database uses centimeters, the other use inches. So what to do? Some of the methods to deal with conflicts are using statistical measures like the mean, median, mode, picking the one that was most recently stored, or finding a creative resolution. Dealing with data redundancy is another challenge because when values are stored slightly differently in two databases, they don't get integrated. They just integrated as two entities. So those need to be identified. Another example is derived values versus storing absolute values. So many methods like correlation and covariance analysis are implemented to deal with these issues. Here is an example of a data quality issue. Suppose someone is checking the price of a stock from multiple sources and then they get different values depending on when these values get updated. And here we can see an example of a missing data. So one site has the 52 range, the other one does not. In summary, we covered data processing tasks and discussed details about data cleaning and data integration.